Okay, Assalamualaikum dan salam sejahtera. Hari ini kita sambung semula kuliah kita. Saya rasa nota ini saya upload dalam website, so maknanya awak pun boleh download dan tengok. So pada 1 jam hari ini kita akan melihat contoh-contoh pump positive displacement dan beberapa kelebihan masing-masing dan sebagainya. So saya harap pelajar boleh menulis dengan detail advantage dan disadvantage antara centrifugal pump dan juga positive displacement dan sebagainya. Okay, ini kerana di dalam final exam saya akan kemungkinan besar akan bertanya berkenaan dengan soalan yang melibatkan explanation dan saya harap awak dapat explain dengan baik. Okay, so for today we continue our lecture about positive displacement pump, and we would like to see a few types of positive displacement pump, a few example, and the advantage, the disadvantage, and the usage of each positive displacement pump. Okay, there is a lot of positive displacement pump, but the most important thing that you need to understand about positive displacement pump is, so it's transfer liquid in terms of volume. So means that it might be rotate, it might be moving in linear motion, but the idea is it transfer the liquid volume by volume. So we have the common one is might be we have a rotary pumps here. So and then we have a multiple rotor rotary pumps. Actually the mechanism is quite the same, and the different one in positive displacement pump is the reciprocating pump, because the reciprocating pump it works like a piston. So piston contohnya macam picagari lah, itu yang paling mudah untuk awak faham. Okay, yang ini antara beberapa data, a few data about the positive displacement pump. I think you could see here. So the maximum capacity and so on and so forth. So it is it is okay for you not to remember this one, because it keep changing, because the numbers here, the value here is not limited to this one, because it depend on the manufacturer to build it in small scale or the large scale. Okay, so I want to, okay, I see, I think you already have these notes. You could download it and you could read this one, but I want to show you is about the sliding vane pump here. So the advantage is might be it's can operate with erosive liquid, and but however it can handle with the solid, but it cannot handle the fragile solid. Means the liquid that mix with solid. So the idea of sliding vane pump is like this. Okay, so you could see that we have a rotor here, a rotating device here, and then this rotating device is not fixed concentric at the center of this casing. So it will fix in a little bit shifted area, so it will create a volume at this area. So you could see that it has vane here. So this vane is fabricated with a spring. Okay, so means that this vane can be go forward and backward. So from the device, I think you could, from this image, you could see that it is clearly that this pump transferred the volume here, transfer the liquid here volume by volume. So means it's transfer liquid here from this area to this area, and until it's reached at this area, and then the water will be flow at the outlet at this part. So means that yes, it has a rotating parts, but the idea is it's not transferring the kinetic energy from the rotating part to the liquid. it transfer the liquid in term of volume. So and then this is the sinusoidal. The sinusoidal is actually it's create volume inside that pump casing, but it has a sinusoidal plate like this. So mean plate with a little bit curve like this. Okay, so if you see, if you could see from the side view here, might be the plate is something like this. Okay, it's curved like that. So because the curve is similar with the sinusoidal curve, so it's called that the sinusoidal because it moves. You could imagine in when it's rotate at certain area will have the upper part and another area will have the lower part here. So I hope you could imagine. So it's something like this one. Okay, so it's curved like this. Okay, and then if you draw it, okay, it's curved like that. Okay, so this is actually the technique to create a volume and to compress the liquid to the outlet. So and then another thing, another pump is the impeller pump. So the difference between the vane and the pump is vane normally the pump here is can be moved forward and backward. So but the vane here, the impeller means it has an impeller like centrifugal pump, but again the usage of that impeller is not to transfer the kinetic energy, it's actually to create a room. So satu ruang untuk air disimpan dan dipindahkan. So the usage of that impeller is to create a space for liquid to be transferred according to time. So again, so it has advantage here, but the disadvantage here, the flow rate is small and it has problem. We have a wear and tear problem of the impeller. So for example, this one, because we want to create, okay, first I think you could imagine that we have impeller, the black one, this one. Okay, so this impeller is rotate at certain speed. So and then the rotation is cannot be so high because it's not to transfer the kinetic energy. It's the usage of this impeller is to create an area or the volume where the water will flow inside that volume and being transferred from time to time. Okay, the problem is this impeller need to be tight because we learn about the I think after this we will learn about a few equations that relate with the positive displacement pump. So one of them is the volumetric efficiency. Because in positive displacement pump, we don't have any manometric efficiency, we don't have the efficiency like centrifugal pump, because the main idea is we are transferring the water with the volume, volumetric here. So the main the important things is we must make sure that each space here is really tight. So mean we don't the water is not leaking. So means that the impeller here need to touch the casing here very hard, and then because we have motion here, so along the time there will be a wear and tear. Kita akan ada hakisan di sini, so dia akan ada wear and tear. So lama kelamaan efisiensi dia akan turun. Okay. So jadi yang paling mudah kita boleh lihat beza antara vane dengan impeller ialah selalunya vane adalah dia berfungsi dalam keadaan yang boleh bergerak ke depan ke belakang. Selalunya takrifan orang akan beri. Okay, kemudian we have another type of pump called peristaltic. So the ideas of idea peristaltic is because you can read here. So it is reflect our esophagus to bring our meal, something that we eat from our mouth to the stomach. So means that it works in peristaltic motion. So the idea is this one. I think we already discussed about this one. Means that sometimes we need to use positive displacement to make sure that there are no contamination of disease of in our liquid. So this pump is usually used in hospital, especially for the blood dialysis. So mean we transfer the patient blood from here, and this blood is moved by the idea of this one. So this is the schematic diagram. So if you could see, if this triangle parts here rotate at certain speed, so it's create volume here. So it's create volume for liquid here. So in this case, it's create the volume of blood here. So and then this volume of blood will be transferred to the machine or and return back to the patient along the time. So you could imagine this one. And then to reduce the contamination probability, so we change the hose every time we use this machine. So it is not means we cannot use centrifugal pump to use in blood dialysis. So and then this is a cavity pump. So this is especially to move liquid that is very slurry. So for example, we have the toothpaste or something like that. So we cannot use centrifugal pump, and sometimes it is not okay. It is not efficient to use piston pump, because the way we flow, the way we move slurry liquid is by moving it in slow motion. So mean piston pump, yes, it is in theoretical, it can be used to move slurry motion, but the problem is when we press the slurry, yes, it can be goes out. Okay, I think you could imagine about quick some plate or something like that. So means you have a dough, and then you can push it, and it can be flow out. But the problem is we cannot suck a slurry into our piston pump. That's why when you see people who do biscuit and something like that, so they will put it at the back here, okay, because they cannot suck the dough. Okay, so same with this. If we have a toothpaste, for example, a very high viscous liquid, so we cannot push them even in slow motion. But what we need to do is we need to massage it. So we transfer it in slow motion and continuous volume. So the continuous volume can be created by having this type of spiral shaft. So mean you could imagine that, for example, this is the moving shaft. Okay, so this is the moving shaft. So you could imagine that when the shaft is moving, so we massage. Okay, we massage the liquid, the slurry part in slow motion, and then the slurry parts can be flow from from the big tank here, for example, and into another tank. Okay. So idea dia ialah kita tidak tolak dia sekaligus, kita massage dia. Selalunya orang cakap kita akan urut sikit. So macamnya awak boleh imagine kita uli dough dan sebagainya. Itu dia punya main idea. Okay, and then kita the techniques or the design of the shaft here is actually depends on the type of liquid and so on. Okay, sometimes this design is actually has their own advantage. So yang advantage tersebut mungkin saya tak dapat terangkan kerana ia bergantung kepada sesuatu application dan sebagainya. Kadang-kadang kita buat trial and error, kita cuba bentuk ni sesuai atau tidak dan sebagainya. So and then we have external gear pump. So why we call this as a gear pump? Because we have a gear here. So and then this gear again, it's not transferring the kinetic energy. it's only to create a space, a volume for water, for liquid to enter it and to be transferred to another place. Okay, so cuma yang normally we have three types of I show you the common three types of gear. So one is a spur gear. So one is the helical gear. So we have it's inclined a little bit here, and then we have a herringbone gear. So the herringbone here, so the shape is something like this one. Okay, so it's located like this one. So and then the flow will flow here and then it transferred to another place. So this is another so for gear pump. So okay, this is the example. So as you could see here, so it has it create area here. So when the gear is rotate, so it's push the liquid to move to the larger space here, and finally it will press or it will push to flow to the outlet at this one. Okay, so another type of gear is a lock pump. So it is something like we have a design like this one. So it's something like a gear like this one, but normally it don't have the exactly the same design. So it just a triangle of four of them. Okay, so connecting each other like this one, and then when it move, so as you could see here, when it's moved, so it create its transfer. So it transfer liquid from one place to another place until it goes to the outlet here. So we have two parts of this one is to increase the volumetric. So it is okay for us to have only one loop like that one, but to increase this, the volumetric, so we have two, because if you could see at one time when when this loop rotating at that one, so means that it's push this one into to this direction. So at the same time, it could carry small liquid from left to right at the top, and at the same time it's bring water at the bottom, and then it could push, it could flow water to the outlet like this one. Okay, so this is another type of lock pump. So I think you could explain the usage of this one, the mechanism. So and then this is the multiple screw pump. So this idea is might be same with the peristaltic, not peristaltic, the sinusoidal pump. So because so the difference is the shaft here is not wavy like this one. So the shaft here is actually like a thread of a screw. So that's why it's called as a screw pump. So this is the three screw pump. So because it has a three shaft like a screw like that. Okay, so finally we focus on the piston pump here. So piston pump, so it's actually it works like a piston like this one. So as you know that we have a piston pump here. So it is normally we have a bore here, a casing, a cylinder, a hollow cylinder. So and then we have a piston here. So and then this piston normally like a pichagari. So pichagari is the simple example of piston pump. So when you push and when you pull this piston, so you suck liquid inlet, the volume here. So and then when you push this piston, so you push the water outside, go to the discharge line. So however, it has single acting and double acting pump. So for single acting, so like this one, so this single acting means so it just works one, it acts one one action at a one time. So at one time they will suck the liquid. For example, this one, if the piston is pulled to this direction, so the water will be sucked to this volume, to this area, and then when this piston is pushed, so the water will be pushed to the discharge pipe. So, and then because to increase the volumetric, so increase the volumetric efficiency, so engineers create double acting. So we have a double acting here. So double acting means that when the piston is pulling to this direction, so this area will suck water. They will suction here, but at the same time, the water at this area will be pushed to the discharge pipe. So, and then at the same time, okay, the suction and the delivery is work at the same time. So that's why we call it a double acting. Okay. So, and then for this piston pump, the another two most important part is actually the way we install the valve here, because the valve will make sure that the water will not flow back to its current. It's not. It's prevent liquid from the reverse flow. So the installation of valve here is very important. So another thing in piston pump is we must make sure that the gap here is sealed very well, because if the gap here is too big, so it will not create enough vacuum pressure, so water cannot be sucked into the core. So that is the another not disadvantage, something that we need to take care about the piston pump. So, and then another type of pump is we have a plunger pump. So plunger pump is actually the same things like the piston pump. So this will be go upward, forward and backward to create the vacuum and to suck the water, and then it's pressed to the discharge. Okay, and then the diaphragm pump like this one. So this is the diaphragm pump because it have a diaphragma, diaphragm. So the idea, so this is the real one, but in schematic sketch, it can be shown like this one. So we have the rotating device here. We have a crankshaft. So, and then we have a diaphragm here. So, and then when it's move downward like this one, so it will create a small volume in this one, and then when it's moved outward, so it create the large area. So it will be moved again and again, so it can flow liquid, especially liquid mixed with solid, from one place to another place. So so this is the basic idea. So mean the pictures of a few type of positive displacement pump. So I think you could make your own readings by looking a few type of positive displacement pump. At the same time, make sure you could differentiate the usage, the advantage, and then you could determine the advantage or the disadvantage for each type of pump.